Hola, buenos días.
Buenos días, Enrique. ¿Me escuchas?
Sí, te escucho.
Perdón.
Estaba viendo a ver aquí si puedo meter un fondo para que no se vea el desastre de mesa. A ver, fondos virtuales.
Va a depender del equipo que tengas.
Bueno, uy, se ve al revés.
No,
Ahora.
se ve bien, se ve bien.
Que lo tengo que poner así.
Claro, es el formato espejo, ¿sabes? Porque si no, nosotros lo leeríamos al revés.
Vale, me lío. Porque lo estaba viendo yo al revés.
Sí, normalmente, buenos días. Normalmente
Buenas.
cuando te creas la cartela para detrás, la haces en modo espejo.
¿Me oís?
Sí. Aquí podemos compartir pantalla nosotros.
Sí, claro.
Vale. A ver, por ejemplo, la pantalla 2. Y pongo la presentación. ¿Se ve la presentación?
¿No?
No, ahora mismo no estamos viendo nada.
¿Estás probando, Enrique?
Está la presentación puesta, en teoría.
No, pues no se ve.
A ver. Perdón, es que hay que darle otra vez al botón compartir, que estoy acostumbrado a Teams que da
Sí.
directo. Perdón, culpa mía. ¿Ahora sí?
Ahora sí.
Vale. Pues vale.
Vale, prueba a compartir yo ahora, por si
Vale.
acaso.
Sí, tengo que dejar yo.
Eso te iba a decir.
Mm.
A ver.
¿Cómo te llamas el señor de Nunsis?
Carlos.
Carlos, por no llamarte soporte. La idea aquí es que, bueno, sí que se ve, Carmen.
¿Se ve? Vale, perfecto.
Vale. Van a entrar, somos Carmen y yo, y hay otros dos señores, Pedro y Manuel. La idea es que empiece yo hablando, yo le daré el turno de palabra a Pedro, ¿vale? Entonces, nosotros, cuando entren ellos, el que aparece en pantalla, ¿se nos das tu paso o cómo va? ¿Cómo va?
A ver, os doy paso. ¿A qué te refieres?
Me refiero, el que aparece en pantalla es el que está hablando en ese momento, pero no hace falta, se hace automáticamente.
Correcto.
Vale, vale. Entonces como una reunión normal, un poco más o
Claro,
menos.
lo único que me tenéis que decir es si abrimos a y media, entiendo.
Sí, sí, en teoría las otras dos personas se debían conectar. Pedro me dijo que sobre cuarto, sobre 20 se conectaría.
Sí, Manuel
Vale,
también, hay cuartos, sí.
pues como en el seminario tenemos que darle a iniciar seminario para que se
Ujú.
retransmita y puedan entrar los espectadores, si os parece como 5 minutillos antes, porque si son muchos van poco a poco, ¿sabes? Damos
Mm,
entrada a los espectadores y digamos ya estaríamos en directo.
vale. Pero los
Vale.
espectadores no se conectan por YouTube a la aplicación, a la web app del Congreso.
No lo sé.
Sí, ahí hay un enlace de YouTube.
Sí, se conectan entonces por la plataforma de Ventu.
Sí,
Sí,
Vale.
vale. Ellos en principio este enlace no lo tienen.
Vale, vale, vale.
De hecho, bueno, comparto pantalla un momentito y lo ves. O sea, esto es ¿ves la pantalla?
Ujú.
Eso es la aplicación esta de Ventu, ¿vale? Y aquí es el link este de YouTube, que en teoría es esta reunión.
Vale,
Que,
perfecto.
¿vale? Yo no sé si ya se está retransmitiendo o no, pero bueno.
Sí, porque me pidieron los de Ventu que les pasara la URL con antelación para poder embeberlo en vuestra
Sí, me ha
plataforma.
enviado un correo Sara, que es la de Ventu, que necesitará la URL como una media hora antes o eso de
Ya,
cada una de las sesiones
mm,
para esto.
ya la tiene.
¿Vale? Y esto supongo que ellos entrarán aquí, le darán al play y simplemente visualizarán. Y aquí es el link
Correcto.
de YouTube, que en teoría es esta reunión. ¿Vale? Y ellos
se
van
está.
como eso me dijo, van como unos segundos detrás,
Mm,
pero
Sí,
entonces,
tiene
como son
delay.
las plenarias y todo eso, no pasa nada porque ellos aquí escriben las cuestiones
vale.
Ujú.
y el que haya de moderador en su momento, pues cuando acabe el plenario de hablar, le lee las cuestiones al plenario y las contesta.
Vale, perfecto. De todas maneras, hoy tenemos hasta las 11 más o menos, ¿no?
Sí, abrimos nosotros para presentar el congreso y después hay un plenario.
Plenario.
Plenario, sí. Ya mañana,
Mañana hay dos plenarios, más o
eso.
menos organizados casi uno detrás del otro, pero a mediodía, más o menos. Bueno, no,
Bueno,
no es uno detrás del otro, sí.
no, yo tengo a las 12 que
Sí,
termina más o menos y media, y el siguiente es a las 4.
eso
A las
es.
4, sí.
Y después el viernes hay un plenario y después en Zoom, como parecido a lo que hicimos ayer, una
Sí,
mesa redonda y la closing, la metemos ahí y ya
correcto,
está.
correcto. Que
Perfecto.
la mesa redonda comienza sobre las 2:30
Claro, es que en
y
los
la...
plenarios y la opening pues no hay una interacción así tan fuerte de los que atienden, pero claro, los que son una mesa redonda, pues si la gente hace preguntas es mejor que estén una interacción más en directo.
Sí, en principio lo íbamos a hacer en formato webinar y ya me dijo Fanny que lo
Sí, es que lo
cambiábamos a
estuvimos hablando
reunión.
porque las cuestiones, y si hay un lag de unos segundos, pues claro, ya no hay conversación, se corta.
Claro.
Enrique,
Sí.
una cosa, cuando hable, o sea, tú presentas a Pedro, ¿verdad? Y
Hmm.
cuando acabe él de hablar, entonces yo ya le doy las gracias y presento a Manuel, ¿o cómo
Sí, le das
hacemos?
las gracias y presentas a Manuel. Es que creo que es mejor que yo presente a Pedro y tú presentes a Manuel. Porque yo conozco a
Vale.
Pedro pero no conozco a Manuel.
Ya, ya.
Aunque entre ellos se conocen.
Sí, sí, claro, claro. Y yo tampoco te creas que. Bueno, sí, habremos coincidido, pero vamos. Pero bueno, yo presentación voy a presentar el nombre y poco más, ¿no? O sea,
Sí, sí. Este señor está, el presidente no sé qué, y
eso
Pedro
es,
está, es
tal.
miembro de SEMNI y de Ecomas.
Eso es, vale. Vale, y entonces luego cuando acabe Manuel sigo con la presentación, con el Practical Information, tal, tal, y ya cierro y ya está, ¿no? O
Sí,
sea, vamos.
insiste, porfa, en que se ciñan al tiempo, que corten, que los moderadores
Ya,
corten.
vale, vale.
Eso siempre lo decimos, pero
Sí,
siempre...
bueno, eso sí. Luego harán lo que. Pero bueno. Vale. Oye, y luego la plenaria de Paco es en este mismo link. Claro, ¿yo qué hago? ¿Yo me salgo y accedo desde la plataforma? Porque en principio deberíais estar conectados tú y él o...
Sí, pero bueno, pues creo que podrás hacer lo que quieras, da igual que estés dentro que fuera, ¿no, Carlos? Es que en la siguiente, ahora hay media hora de la opening
Sí,
Y
luego seguir
después
el
hay la
plenaria.
plenaria, que entrará otro que se llama Francisco,
Sí, Francisco Chinesta.
Francisco Chinesta,
Sí.
y yo soy el que lo introduce, digamos.
Es el mismo link, o sea, mantenemos la sesión abierta.
Sí, yo ni me salgo ni nada y Carmen sí que se quiere salir, pues que haga lo que quiera. Supongo que sí, lo más normal es que te salieses, pero bueno.
Es que igual queda mejor que estéis solo los dos, ¿o qué? Porque ellos imagino que verán los o sea, la gente que está conectada, ¿o qué?
Posiblemente. No sé. Sí, puedes salirte, que no hace falta.
Vale.
Si hiciera falta que entraras, pues oye, pues ya veríamos, pero no creo.
No.
Yo estoy aquí en el despacho desde las 7:30, nervioso a ver cómo va esto.
Pues yo es que tenía que sacar el perro, por eso he hecho un poco más, pero vamos, estoy cardíaca. Yo desde ayer que... Ojo de la luz, no sé si me ve mal por el reflejo.
¿Te has podido mirar si de la Contributed Session puedes? Es que estaba puesto así porque primero estaba yo el viernes y tú el jueves porque estaban las dos del PhD el viernes. Entonces te puse, yo, bueno, dos para mí y dos para Carmen. Pero claro, ahora como se pasó una del esto al jueves, solo hay una que coincida. Con lo cual
Vale,
cabe
o sea, solo
a
coincide
cambiar,
una.
solo coincide una, que es una del viernes.
Vale. Vale, yo con tal de
Entonces,
que no me coincida eso, de todas formas ahora
yo
cuando
creo que
eso
no
le
te
echo un
coincide ni
ojo.
con con mi simposio ni con lo de los PhD.
Vale, vale.
Pero bueno, si dices, mira, es que esta no quiero estar porque quiero ir a ver no sé qué, pues bueno,
Vale,
pues
vale. Sí, lo
lo
hablamos, lo que sea,
apañamos.
pero vamos, en principio, si no me coincide y tal.
Y después para la mesa redonda, pues estaremos nosotros con ellos y ya está.
Vale.
Pues ayer nos envió un correo uno de Lyon que había habido una tormenta o no sé qué y habían caído los servidores de la universidad que se ve que se habían frito y no podía acceder al correo donde tenía las credenciales, no te lo pierdas.
Hola, qué desastre. Si es que aquí pasa de todo.
Ay, madre. Y había otro rezacao que era compañero de tu amigo.
Ya se os puse el WhatsApp, digo, si escribe un tal James Adler, digo, pues eso.
Escrito esta
Pero este
noche.
ha escrito a las 2 de la mañana, que también
Ya.
ya le dije a Ludmil, digo, si se va a inscribir, digo que lo diga cuanto antes. Y cuando lo he visto esta mañana, digo, os voy a matar a esta gente. Pero bueno.
Eso es normal.
Jo, pero que es hombre, pero ostras.
Las plataformas están dados de alta.
Adler
Porque
también.
sí, a todos los que eran...
No, pero es que este no es chair, creo, ¿eh?
pues
Este organiza.
entonces no estará dado de alta.
Claro, es organizador, pero creo que no era chair.
A los que eran clave, que eran los chairs, los dimos de alta.
Claro.
Porque al final sí
Ya.
van a entrar, vamos, antes o
Sí,
después.
sí. Ya. No, pues este luego, bueno, si no se lo comentaré luego a Amparo, bueno, habrá visto el mail o lo que sea. Más que nada por darle de alta en la plataforma para cuando pueda.
Que estamos en directo, nos están viendo, nos están viendo.
Ah,
Y Fanny nos dice que se te ve bostezar.
que se me bostezar. Jolín.
Hola, buenos días.
Buenos días, Manuel.
Buenos días, Manuel.
Hola,
¿Qué
Carmen.
tal?
¿Qué tal? Hola, Enrique.
¿Qué tal?
¿No ha habido problemas con los enlaces?
Espera,
No,
voy a
no,
probar si me funciona
entré
bien el
bien.
audio sin los cascos. Creo que quedará más bonito.
Yo llevo los estos porque si no,
Sí, yo también tengo los pequeñitos. Lo que pasa es que yo
pequeños.
no me fío de los inalámbricos porque ya me ha pasado alguna vez de quedarme
Sin batería.
sin batería. Entonces, lo pasé una vez bastante mal y aquí tengo los cablecitos porque es que
Sí,
no me
sí.
fío, no me fío.
Sí, a mí
La
me
verdad es
pasa
que
también alguna
no
vez.
eran, también es cierto que no eran de una calidad de esta, ¿no? Pero bueno, en fin.
No, por si acaso, sí, sí.
Sí, sí, sí.
Yo creo que los tengo cargados, por lo menos para esta media hora. Yo creo que aguantan. Luego ya iré cargando, pero
Ok.
a ver, a ver.
¿Se me oye bien?
Sí, muy bien.
Vale, es que me he quitado los cascos porque queda más bonito, digo yo, más estético.
Muy bien. ¿Qué tal? ¿Cómo va todo? Con los nervios de empezar, ¿no? Porque uno nunca sabe.
Estoy aquí en el despacho desde las 7:30 de la mañana.
Cardíacos.
Sí,
Pero
sí,
nervios
normal,
todo, ¿eh? Todo nervioso.
normal. Nosotros el viernes pasado estuvimos organizamos en Málaga el Day 2021. Bueno, es el Congreso de Hiperbólicas que se celebra cada 2 años. Lo que pasa es que, bueno, se tendría que haber celebrado el 2020, no se pudo celebrar y de hecho se ha pospuesto para el 2022. Pero como había bastante tiempo sin ningún acto así, total, que se decidió hacer una especie de una jornada de un día donde entraban, pues eso, 4 personas y era, bueno, un formato todo online y tal, porque participan gente de, pues eso, ¿no? De Asia, Europa y América fundamentalmente. Y madre mía, qué nervios, porque claro, dependíamos lo típico, que los panelistas utilicen razonablemente bien la herramienta. Era el Webex de Cisco, que no era el Zoom, que entonces había gente que no estaba habituado.
Acostumbrada.
Uy, uy, uy. Y lo pasamos con los nervios. Con los nervios, con los nervios.
Nosotros para las paralelas también hay una aplicación que está embebida en la propia web. Sí, y también no es el Zoom. No es muy distinto. Pero siempre el primer día, la primera vez que la usas, pues tiene sus peculiaridades. Como
Sí. Yo, bueno, yo por ejemplo estuve, la gente está de Siam, como tienen ya también bastante experiencia y tienen tanto congreso y tal, a ellos la verdad es que, bueno, lo que tienen también es algo parecido a Zoom embebido en su historia y les funciona razonablemente bien. Bueno.
Bien.
Yo lo que tengo preparado es una intervención pequeñita, un par de minutos, una cosa así.
No hace falta.
No
Nosotros
tengo mucho más.
un poco lo que es el congreso, la plataforma y tal, y más o menos la mitad. Buenas, Pedro, buenos días. Pues,
Buenos días.
Hola Pedro, ¿qué tal? Buenos días. ¿Qué tal?
Estamos aquí haciendo deberes institucionales como tú.
Ya te veo, ya te veo. Ya te veo. ¿Qué tal? ¿Cómo va todo por allí por Barcelona?
Pues bien. Oye, yo una cosa privada entre Manuel y yo, ¿eh? Oye, yo hablé con Manuel.
Oye, cuidado que
Espera.
lo que se habla aquí se está retransmitiendo en la
Se
plataforma.
retransmite el YouTube.
Nada, entonces ya
Pero no me han escrito nada, simplemente te respondo. Yo sé de lo que me ibas a decir.
Yo sí escribí a Luis y
Vale. Les doy un toque a ellos, a ver qué me dicen, ¿vale?
Vale, perfecto.
¿Vale? Esto lo hemos montado porque lo grabamos aquí y se retransmite en directo en YouTube en la plataforma del Congreso. ¿Vale? Así en la sesión estamos solo nosotros, pero nos ven dentro de la plataforma.
Vale.
Si alguien se ha conectado ya, pues nos estará viendo, nos está escuchando esta conversación.
Vale.
Para que no hablemos mal de mucha gente, ¿no?
Eso no hay que...
No.
Eso nunca.
Bueno.
¿Y cuánta gente o sea, vosotros vais a ver, no se van a ver aquí en esta sesión de Zoom cuánta gente hay
Conectada? No lo vamos a
se
ver.
verán en el canal de...
Sí, lo verán directamente en lo que es la
Plataforma.
plataforma del Congreso.
Vale.
Pero sí habéis llegado a los 100 participantes o algo más de 100, ¿no?
280.
¿Cuánto?
Tenemos,
2,80.
2,80. Sí.
2,70 y pico han pagado o una cosa así, siempre. Aunque...
Madre. No, el tema
yo
de...
el número lo diré después, eso no,
Sí.
eso lo voy a decir de todas maneras, no pasa nada.
Por eso que el número de... Que los eventos online lo que tienen es que se suele apuntar más gente.
Sí,
Se
después,
suele apuntar más gente.
apuntar, sí, después que estén ya es otra historia.
Ya, sí, ese es el principal hándicap, ¿no? Pero es cierto que se apunta más gente, ¿no? Es decir, que el número de participantes crece normalmente. Cosa que está bien, porque eso, por un lado, en cuanto a la sostenibilidad del evento, pues no hay ningún problema.
Sí, sí. O sea que la verdad es que, mira, nosotros hicimos hace poco un evento que estuvo Enrique, ¿no? El Atmos, que ahí había unas 100 personas apuntadas. Y mira, como todo, no había paralelas y tal, más o menos manteníamos una media de 50.
Está muy bien.
Pero claro, hubo el couple problems, que es uno que había 300 apuntados y que se ve que en las plenarias el pico también fue de 60. Entonces dices, ostras.
Sí. Sí, no, eso es así. Eso es así. Nosotros en el feria de este año, pues bueno, pues la participación ha sido mayor porque era híbrido, el formato híbrido, entonces estaba la parte presencial y la parte online, pero luego es cierto que la participación luego ya en plenarias y tal, pues claro, variaba considerablemente con respecto a esos números, ¿no? Es decir, que eso sí se tiene.
Bueno, es el signo de los tiempos, ¿no?
Sí. ¿Pero creéis que se va a mantener esta historia de híbrido forever and ever o no?
Yo creo que depende de mucho del formato. Para cosas pequeñitas puede que sí. Para cosas que haya poca gente y que te ahorres viajes y tal, sí. Para cosas un poco mayores yo no le veo mucho sentido. Es decir, la gracia de un congreso grande es ver a la gente en los pasillos.
Sí.
No sé. Yo supongo que está bien que exista como posibilidad y que realmente sin la pandemia no hubiésemos desarrollado tantas potencialidades ni nos hubiésemos dado cuenta de todo lo que tiene. Pero, hombre, creo que sí que eso que dicen que llega para quedarse, hombre, sí llega para quedarse, pero no para ocupar todo, ¿no? O sea, no sé, lo de París que se hizo al final de Comas de París, que se hizo online, hombre, estuvo bien para ser online, pero no sustituye a la experiencia del congreso.
Yo, mi experiencia personal muchas veces en los congresos grandes es que justamente vas para conocer gente, ¿no? Entonces, ese, por ejemplo, tú a tú que sueles tener un congreso grande, no lo terminamos, o por lo menos también es cierto que a lo mejor es un problema de la gente de nuestra generación, Pedro, que necesitamos, a lo mejor es eso, ¿no? Es decir, que somos de otra generación y pero a mí, ya te digo, a mí me cuesta bastante, soy una persona, a ver, en general bastante tímida, ¿vale? Y entonces me cuesta trabajo, pues eso, ¿no? Si no estoy delante de la persona y tal, pero si no me cuesta más trabajo en una intervención así online.
Buenos días, Paco.
Y tal. Hola,
Buenos días. Buenos días, Pedro.
Oye, entonces la conferencia de Paco también va a ser así, o sea, va a ser en esta plataforma Zoom, pero la vais a pasar por el canal de YouTube.
Sí, y se ve en la plataforma del Congreso. Y Paco, te tengo que avisar que todo lo que se está diciendo aquí se está retransmitiendo.
O sea, para que no diga ninguna barbaridad, ni ahora ni después. Gracias por avisar, Enrique, que ya estaba preparada. ¿Ves? Ahora ya no tenemos ganas de hablar.
Lo hemos callado.
Se ha cortado ahí.
Y Paco, que me alegró mucho aquel mail que me enviaste con tus nuevas aventuras.
Hombre, ahora cuando organicemos la primera reunión en Bali, verás. Muchas gracias, Pedro.
¿Y cuándo prevés? ¿Tendrás que ir mucho tiempo allá o irás?
Bueno, un mes allí, un mes aquí, pero sí, más o menos en 5 años, un par de años seguro. Poco a poco y solamente una parte del tiempo, los veranos y cosas así, pero bueno, es una oportunidad también.
Sí, sí. No, está muy bien, está muy bien. Yo creo que además está muy bien escogido el tema. Está muy bien, está muy bien. Te felicito mucho. De verdad.
Gracias, Pedro.
Enhorabuena.
¿Cuántos tenéis? ¿Cuánta gente?
Sobre unos 270 y pico se han inscrito.
Ah, muchísimo, perfecto.
Mm.
Bueno, ¿cómo se lleva en España la derrota de ayer?
Dime,
Mira,
No
Bueno,
vamos a llamarle derrota, vamos a decir que no ganamos.
eso. Vamos a decirlo así.
Los franceses son positivos, dicen, jolín, los buenos no ganamos.
Ay, ay.
bueno, tú sabes que en mi casa mi mujer es italiana, entonces bueno, estábamos ahí
¡Hola,
Oh.
un poco igual, ¿no? Pero la verdad es que a mí no me gusta el fútbol, me parece muy aburrido y nos enterábamos por los gritos. Pero en mi barrio se oyen igual de altos los gritos cuando marca Italia, juegue con quien juegue. Porque el otro día, o sea, incluso Antonio Huerta me escribió un mensaje diciendo, oye, ¿tú también oyes los gritos de la gente cuando marca Italia? Y efectivamente, o sea, en nuestro barrio, marca Italia cuando jugaba con no sé quién. Y coño, se oyen los gritos, tú te enteras de los nombres. Está lleno de italiano. Y ayer se oían los goles de todo el mundo, claro.
Yo ayer tuve una reunión con colegas italianos y en fin, hoy no voy a aparecer.
Ay, ay.
Bien. Yo no he visto ningún partido de fútbol este año. Entre el Congreso y la niña,
¿No? Vaya. Que ha sido papá hace poco.
sí. Pues ahora tiene 8 meses.
Bueno, bueno,
Pero ahora está dando guerra por la noche, todas las noches.
bueno.
Bien.
Oye,
No pienses, Enrique, que no, después paran de dar guerra, ¿eh? Dan guerra toda la vida.
Ahora
Digamos que son guerras diferentes.
Evoluciona.
Pero
Ay, ay.
tú ya estás en guerra para toda la vida, Enrique.
ya.
aparte que es parte del convenio con el sindicato, ¿eh? O sea, si no hiciese eso, el sindicato iría a decirle que cómo es que no va a guerra.
Digo. Sí que sí.
Bien. Bueno,
¿Vosotros controláis cuánta gente hay en la otra plataforma o algo? ¿O no?
pues lo acabamos de preguntar a Amparo y supongo que alguna manera habéis de saberlo. Amparo es la técnica aquí de la universidad que está pues, gestionando un poco la parte que hay detrás, Amparo y Fanny. Sí, supongo que sí que habrá manera. Lo que no sé cómo.
Enrique, ¿cuánto tiempo tengo que hablar?
Eh,
Yo me adapto, ¿eh?
Tienes 1 hora como máximo,
¿Para hablar o para preguntas incluidas?
incluido todo.
Incluido todo, vale. Si a mediodía no he parado, vosotros me avisáis, ¿eh?
Vale. La idea es más o menos de 10 a 11, una cosa así.
Muy bien, perfecto.
Significa como mucho y sobrar algo de tiempo para la opening.
Sí.
Prácticamente.
Yo voy mirando el reloj y me dejo 10 minutos al final o 15 minutos para contestar preguntas si hay. ¿Quién las pone las preguntas? ¿Se mandan por chat como de
Sí,
costumbre?
en la plataforma hay un chat y yo te las leeré.
Ah, muy bien, perfecto.
Bueno, me está diciendo que son las 9:30. Vamos a empezar ya cuando queráis. Voy a compartir pantalla. Good morning to everyone. Welcome to the JIC 2021 conference. So this is the sixth ECOMAS Young Investigators Conference, and is held virtually here in Valencia, and is organized in collaboration with SEMNI and SEMA, which are the two Spanish associations that are in ECOMAS, and also with the support of the UPV, my university, and my institute I2MB. Well, here we are the conference organizers. Carmen Rodrigo from Zaragoza. So she's member of SEMA, the Jose Martinez Casas, that he works with me at UPV, but now he's in a parental leave. He has a child, a baby, 2 weeks ago, so he couldn't join today to the conference. And finally me, Enrique, that I'm member of SEMNI, and I'm also working here at University in Valencia. Well, this conference has been organized, okay, in my university, but in collaboration with some very important people that is in the backside of the conference, organizing all the small details, all the things that we have to take into account, sharing the experience, their opinion, and sometimes their emotional support. These are Amparo, is member of my institute. She's a technical staff, and is supporting all the details regarding the abstracts, the platforms, controlling that everything goes smoothly. Fanny Collado, she's a technical staff at my university. She's in charge of organizing events, contracting the platforms. This is a new experience for all of us, this kind of virtual platform for having the conference. We start with a presential conference 2 years ago. We moved, as you know, to a hybrid conference. We organize everything in a hybrid format. And finally, like in January, we decide to change to a fully virtual conference. And all these things have been possible thanks to Fanny. And finally, we have Marina. She's in charge of the social media, of LinkedIn, Facebook, all that kind of things related to communicate to the big audience the development of the conference, of what is happening, making advertisements to you, all that. Well, I have to thank a lot the effort to making this possible. Also, we have also some students at our university that are in charge of those small problems that are having, or that could happen. We hope don't have problems, but we should expect some of them, of course. These are the survey policies. They will be in each session, in each parallel session, with an initial name that is TS, technical staff, okay? So they are in charge of solving all your small problems regarding the webcam, the microphone, or whatever is happening during the online event. And also we have the students at my institute that help us to control everything in the conference, the abstracts, or all these things that happens during the conferences. Well, you know that we have a thing, we thought that we want to increase what is the interaction between the participants, okay? So we risk on that, and we move to a fully online event and on in vivo event. That means that there is nothing pre-record, so everything will be in streaming. So you have to share your screens, all this stuff. So the risk on that is that since this is an streaming event, something could happen and we have to solve in real time. For that, we have a support staff that is one member in the conference platform that is a GIG support. You can contact it directly. So there will be, in this case, Amparo in behind, and she will answer all your questions. And also you can contact with the standard email for the conference that you are that you have already sent some emails before, and here is the address if you want to copy that. Next, I would like to share the success of this conference. There were more than 270 registered participants. So at the beginning, we expect to have 150, something like that. But we got a very nice surprise in Christmas. This is something like a Christmas present. And we got around 270 abstracts, even some more, I guess. But finally, we got 270 registered participants. We have 19 mini symposia, and we are running 6 parallel sessions during these 3 days. Also, this is a, let's just say, international, but European mostly conference. We have 23 different countries, but 6 countries outside from Europe, which is quite impressive for me. It's they're really, really nice news for us. Then, in representation of all the associations that makes possible, that are also behind and supporting the conference, we introduced these 2 speakers. First is Pedro Diaz, which is member from SEMNI and also member of the managing board of ECOMAS. Please, Pedro, the floor is yours.
Thank you, Enrique. It is my great pleasure for me representing ECOMAS and SEMNI in this opening of this GIG 2021 event. So the organizers, Enrique, yourself, were kind enough to invite me. And since I belong to both the governing boards of ECOMAS and SEMNI, I was very happy to accept the invitations. And actually both presidents, Professor Fernando Auricchio, who's the president of ECOMAS, and Professor Elias Cueto, who's the president of SEMNI, did expressly mandate me to make this welcome, and they are sending their warmest greetings to all of you, to the organizers and the participants of this conference. So the Young Investigator Conference is an ECOMAS initiative that aims at making more visible a very important part of the community, which is the young people in the community, which is by definition the future of the community. Okay? So this was very well received, this initiative, by all the ECOMAS member associations. And recall that ECOMAS is made of 23 local or regional associations. Now, actually, many of the actions of ECOMAS are oriented to the young members. The PhD Awards, the Olympiads, the Young Investigator Awards, this particular series of conferences. This is because ECOMAS want that this community, this part of the community, the young people, to be visible and also to take the lead. Another advantage is that, you know, in ECOMAS, youth lasts very long. I mean, under 40 years. So that's an advantage or an incentive to belong to ECOMAS or to any of the member associations, is that you can claim that at 40 you're still young. So it's a very good point in it. And actually, the very first edition of this conference was in Aveiro in 2012. And I had the pleasure of participating. I was over 40 in that time, but I was invited, so I went. And that was a very rewarding experience, because the talks were interesting. And the talks were interesting not only because of the speakers, also because of the audience and the participation. I often say that the success of a conference shouldn't be measured on the number of participants, but on the number of backup questions that the chairpersons never use. So in other words, when chairs do not need to use the questions they have prepared, because the audience is making a lot of questions, then the conference is successful. And that was the case of this YIC 2012 conference. And I hope this is also going to happen in the conference who is happening today. I heard in the ECOMAS board, sorry, the reports of the subsequent conference in Bordeaux in 2013, Aachen in 2015, Milano in 17, Krakow in 19. And the impression from these reports was that this spirit of the conference was kept all along the series of conference. And when the decision was taken to appoint Valencia to organize this YIC 2021 conference, SEMNE was extremely happy about it. And SEMNE was extremely happy, not only because of the privilege of hosting this event in Spain, also because a particularity of this conference, which is that it hosts multiple identities. And in particular, the first thing which is multiple here is this is a common initiative with SEMA. And SEMA is the other Spanish society which is in ECOMAS. And to make it simple, SEMA is more, say, mathematics oriented, and SEMNE is more engineering oriented. But as you know, the thematic borders between disciplines are less and less sharp, and the collaboration between the two societies is therefore more and more necessary and natural. And I believe that Professor Manuel Castro, the president of SEMA, who is also with us today, is probably sharing my view. Second, the local organizers are from different teams in 2 universities in Valencia. That's also a rich part of, say, item of this conference. And I believe that this is not new in this series of conferences. In many other conferences, in particular, I remember Bordeaux and Milano, we also had 2 associations of ECOMAS participating in the organization and people from different universities. And finally, I would thank the organizers of this conference for their efforts and their reaction to the pandemic situation. Adaptivity is an active research topic in ECOMAS, and YIC has demonstrated that also the organization of a conference can be adaptive and move online in a short term and with even lowering the fees, which is kind of a difficult thing to do. And also, we have here Professor Francisco Chinesta, and he did exactly the same with the World Congress, which is also very fine reaction. It is a pity that we are not in this moment in Valencia, enjoying the beautiful city, probably the nice weather, I don't know, but here it's raining in Barcelona. However, this is going to be similar to a reduced order model or a hybrid twin. It is reduced or it is hybrid, but it can replace up to some extent the full order model or the reality for many practical purposes. So I wish you the best for this conference. I'm sure that you are going to get the most of this virtual version of YIC. We all look forward to see each other in 3D and not through a screen, but this is going to be in the next editions probably. So good luck and enjoy YIC 2021. Thank you.
Thank you very much, Pedro, for your nice words. Thanks for participating in the opening day. And now it's my pleasure to introduce Manuel Castro from the University of Malaga, who is the current president of the Spanish Society of Applied Mathematics, SEMA. So Manuel, the floor is yours.
Manuel, you have to mute yourself.
Yeah.
Yes. Okay, good morning to everyone. So first of all, I want to thank the organizers, the local organizers, to give me the opportunity to be in this opening session. And well, I don't have too many words to say because Pedro has more or less focused all the main objectives and subjects related with YIC. Nevertheless, as I said to you, I want to thank the local organizers to organize. You know, it's not easy at all, as Pedro said, to organize a meeting concerning 23 countries, as Enrique Nadal has shown us, with more than 200 people participating in during pandemic. Nevertheless, they arrived to organize, I think, with success this 6th JIC conference. So as Pedro pointed out, this JIC conference are an initiative of ICOMAS, and in this particular edition, they are also supported by the 2 Spanish societies that are in ICOMAS, that is SEMNI and SEMA. And I fully agree with the work that he has mentioned. So in fact, there is no sharp frontiers between mathematics and engineering. I think they work common, and I think JIC is a good exponent of that. So there are, mathematical aspects, many real applications where you have different perspectives in order to obtain, the proper results and to improve, the knowledge in this field. And I think JIC is the natural European Congress for young people working in this subject. So I'm very happy that this 6th JIC conference is held in Valencia, and as I said, supported by the 2 Spanish societies in the COMAS. Again, it is a pity, it's a shame that this edition has to be held online, but it's pandemic restrictions. So as Pedro said, this is characterized by the good atmosphere and friendship among all the participants. And okay, this is not so easy if you try to transmit this in 2D, as Pedro said. So I think 3D events, like let's say normal participation is better. Nevertheless, I'm pretty sure that the organizers has been working hard in order to make this event a success, like in the previous one. I've never participated in JIC conference because I'm too old. So in the first edition, I was higher than 40. But nevertheless, some of my students have participated in for example, in the session in the Polytechnic of Milan and Krakow, and they are really. And this is a conference that they like it. So I'm pretty sure that all participants will enjoy the Congress, the subject, and you have several days of intense work. So you start yesterday, and during these days you are going to have 4 plenary conference, nearly 20-mini symposium, the traditional PhD Olympiads, contributed a career forum, and also something that is, I think, quite interesting is, a panel discussion about how to obtain funds at the European level. I think this is also an important. This is important, from your scientific career to progress in mathematics and engineering, but also how to obtain funds. And I think this is also a good idea to have this. And I have more or less the main, the main idea of how a Congress is a success or not. And, I think it's measured in some sense in the, from the quality of the people who participate. And it is clear that here we have, a lot of people that are the present and future of applied and computational mathematics in Europe and also in other places around the world. So I'm pretty sure that this conference is going to be, a great success. And I hope that we could make in person next time, but this is not the case now. So I don't have too many things to say. So enjoy the Congress and do the best from these 3 days.
Thank you very much, Manuel, for your words, and thanks both of you for your support to our conference and for being part of this opening today. Now, finally, I want to comment on some practical information and some details about the platform in which the conference is held. So once that you enter the Event2 platform where the conference will took place, you have this lateral menu in which you can find a lot of information about the scientific program of the conference, the speakers, and the agenda, from where you can access to the plenary sessions, but also you can join all the parallel sessions that we have. Then you have information about the participants and how to interact with all of them by means of the chat or private messages. Here, as already Enrique said, the scientific program of the conference combines plenary sessions with some contributed talks and some talks in mini symposia. Regarding the plenary sessions, they are streamed in YouTube, and you can access to this streaming by using the platform. And then for the questions, you can ask the questions by using the chat in the session. In addition to this plenary, so we have 4 plenary speakers. Francisco Chinesta will be in charge of starting the scientific program of the conference just after this opening session. Then we have Karina Ankundan, which will give their plenary talks tomorrow on Thursday. And then we have Jose Manuel, which will give his plenary talk on the last day of the conference. We want to thank all of them for agreeing to participate and be willing to participate in this conference. Then, in addition to these plenary sessions, we have the parallel sessions. You can join these parallel sessions by using the platform, by using the agenda, where you have all this information. Then once that you click on the session that you are interested in, you will have all the corresponding information, all the talks with the corresponding abstracts, and you can join all the discussions and ask questions by using the microphone or by using the questions chat. We have more than 200 talks that are located in 19 specific mini symposia and some contributed sessions. But also in this conference, we will hold the PhD or ECOMAS PhD Olympiad, in which the finalists of the PhD ECOMAS Awards will present their results. And then we will have 2 prizes for the 2 best presentations in these PhD Olympiads. Also, in order to, well, we think that this conference is very important, the interaction between the participants. And then, although it's a pity that we have to hold this conference in a virtual format, but we have tried, we have done our best in order to get some activities, in order to encourage the interaction between the participants. So these are these 2 dynamization activities that will take place today and tomorrow. And we strongly recommend all the participants to get involved in these activities, because we think that it will be nice and we will have fun. So please feel free to join the dynamization activities today and tomorrow. Also, I would like to thank to the ECOMAS Young Investigator Committee that has participated in this conference, also by organizing some activities. Some of you already participated yesterday in the 3 introductory courses that were prepared for this EGIC committee, and also the Career Forum. I think they were very successful initiatives. And also during the conference on Friday, in particular, we will have a roundtable regarding European funding, where Ana Cruz will present Horizon Europe, and also Ludovic, Judith, and Olivier will talk about their experience regarding this European funding. And finally, well, some information, some recommendations for the presentations. We strongly recommend you to join in advance your session, like 30 minutes, just to test that everything works, that you can share the screen, that your microphone and your camera works properly, all these things. Then also I want to remind you that the talks have a duration of 15 minutes together with the questions. So we recommend like 10 or 11 minutes for the talk and then some minutes for the discussion. We hope that the chair are a bit strict with this timing so that we can keep the timing of the sessions and all the people can attend to the different sessions and to the different talks. Regarding the questions for the plenary talks, as I said, you can write your questions on the questions chat in the session. However, in the parallel sessions, you can use the microphone to directly ask the speaker or also to use the chat. And also we recommend please to unmute yourself and to remove the camera during the presentations of the rest of the people, just to just that there are not noises or distractions or whatever. Finally, I want to thank all of you for attending this opening session. I want to thank all the participants of the conference. I want to thank to Pedro and Manuel for participating in this opening session. Also to thank the EGIC committee for their help in the organization of the activities of the conference, and also to all the plenary speakers and all our speakers and participants of the conference. So thank you very much for supporting this GIG conference. I hope that you enjoy this week, well, these 3 days of conference, and that this is a very fruitful event for you. So thank you very much again, and well, see you these days around.
Thank you very much. So now we are meeting in 2 minutes in the plenary session 1. So, well, we will start in 2 minutes. Thank you very much for coming to the conference, and I hope you really enjoy it. Thank you very much.
Okay. Ciao.
Oh, goodbye.
Bye bye.
Enrique, nos quedamos aquí, ¿verdad?
Enrique, yo salgo pues, ¿vale? Si cualquier cosa me dices. Venga.
Okay.
Yo, si nos molesta, me quedo a escuchar a Paco.
Hello again to everyone. So now we start with the first plenary speaker, Professor Chinesta from Ensemble Paris Tech, France. He is honorary fellow of the Institut Universitaire de France, fellow of the Spanish Royal Academy of Engineering, and awarded with many scientific awards in 4 different fields: bioengineering, material forming processes, rheology, and computational mechanics. Professor Chinesta was president of the French Association of Computational Mechanics, CCMA, during the past years, president of the Scientific and Technological Committee of the French Association of Mechanics, AFM, representative of EUTAM to the CODATA Committee of the International Council of Science, member of the European Artificial Intelligence Alliance, European Commission, as well as member of different committees of ECOMAS and EACM. As you already listened for this presentation, Francisco, Professor Chinesta, is a very big man, and he is known also for the really nice talks he usually gives in the conferences. So I would really like to enjoy this first plenary speaker. So in the platform, you can see a question tab where you can pose your questions. And after the presentation, I will read the question to Professor Chinesta, and he will answer the questions. Thank you very much. So, Professor Chinesta, the floor is yours.
Thank you very much, Enrique. Can you hear me? Perfect. I will try to share my screen. And after 1 year of COVID, I think everything starts to be easy. Can you confirm that you can see my screen?
Yes, I can.
Perfect. So first of all, I would like to thank the organizers. It's always a pleasure to be invited in a conference of young investigators. As Pedro said, you are the future. I hope we are the present, because if not, we are the past, and I prefer the present than the past. So, and I would like, obviously, I would like also to congratulate all the supporters of the Italian Football Club, because yesterday was a very enthusiastic night. So now coming to science, the title of my presentation is The Hybrid Alliance of Physics and Data. So it's something that is in between the modeling of the past century that was based in the laws of physics, and probably something that is very timely, that is the beginning of this millennium, that concerns the use of data or the introduction of data in engineering, and in particular in computational mechanics, data that is manipulated by the artificial intelligence. There are many authors in this presentation. I put only the oldest one, myself and Professor Elias Cueto from the University of Zaragoza. But obviously, you can imagine that there are tens of young and very clever co-authors that I will introduce later in my presentation. As Enrique mentioned, I'm professor at Arts et Métiers in Paris. I'm titular of a chair with ESI Group. I'm also invited professor at the Polytechnic University of Valencia, that is the host of this event. And Elias Cueto is coming from the University of Zaragoza. So now we can move to the difference between probably the old engineering and the new engineering. In the past, obviously, engineering focused in the simulation in order to obtain the performances of the design. We can only produce things that we prove are performant enough. Obviously, in order to make that, we consider models that are expected or representing the reality that we note in this figure on the left, nominal physics-based models. Obviously, we assume that these objects are subjected to loadings in the future, obviously, And we call them nominal loadings that are expected representing the loadings that this object will experience in the future during its life. And obviously, even at that time, data was needed in order to calibrate the models, in order to validate the predictions. And this was a very smart engineering in the past. Now, obviously, as is written in this paragraph on the figure on the right, what is changing, this is clear. Today, we don't sell aircraft engines. We are trying to sell hours of flight. We don't sell electric drills, but good quality hulls. So today we are concerned more by the performances than by the products themselves. So this means that instead of treating a model that represents the reality, we would like to address the real system itself at the present time, at time t, as indicated in this figure on the right. And we would like to consider the real loading and not something that we assume representative of the real one. And we know for the past, at tau lower than t, the value of the loading that apply in the system. And obviously, one engineering is trying to predict, and we would like to predict the behavior in the future when tau is greater than t. And this is diagnostic, this is prognostic. And this is obviously related to the product in service and not only to the design of the product. So this means that in the past, performances were in design. Now we are moving to the performances in operation. In this slide, I try to summarize the main keywords in the new engineering. Obviously, this is my vision. This is only my vision. We are trying to treat systems the more and more complex. I start with the three keywords on the left, on the bottom, that are the more and more large. And obviously, these systems are the more and more uncertain, because reality is uncertain. We are trying not only to design the product, the system, we are also trying to learn from it, to monitor it, to anticipate it. This is the three keywords that are in red. And for what? To make diagnosis. This is in order to know the state of my system now. To make prognosis, that is to infer the behavior of my system in the future. And all this for making decisions, the right decision at the right time. And what is needed for all that? Very easy. The three keywords in blue on the right. We need tools that are accurate and fast. Wow. This is very easy to write, but this is very difficult to perform. Why? Because in the past, when we tried to be accurate, we were not fast. You can see the high resolution finite elements takes a lot of time in order to compute the solutions. And when we are looking to be fast, we degrade, we simplify the model, and obviously, due to this simplification, we are losing accuracy. And now you can understand the main objective of my talk is trying to reconcile these two words, accurate and fast. We must be accurate, but we must proceed in real time because the real decisions in the real life cannot be delayed. Obviously, we have two paradigms. We have the classical physics-based paradigm that I represent in this figure on the right, on the top. Imagine a real system that is represented by the continuous red line. And we have a model based on physics, the standard simulation, that provide the response that is represented by the discontinuous red line. As you can see, it's not perfect, but it's not stupid. What are the main weaknesses of this approach? Obviously, when we have variability and uncertainty, these approaches are quite difficult. And the one that is very well known, solving complex models that are represented by complex partial differential equations has a cost. And this means in many cases, we cannot solve them in real time. So the computing cost is in a certain way a difficulty for the physics-based paradigm. We have another one, the database, that is more recent. Again, take the figure on the right on the bottom. We have the real system, the continuous red line, and we have some data that is good. It's very good because in the points in which I'm measuring, I have the real representation of the solution. At this moment, I neglect the variability in the measurement device. There is no noise in the measurement. But obviously, if you know only the solution in the measurement points, in the blue dots in between, you need to use an interpolation. And when you are interpolating, you can see that you are lost in a lot of details. We have the tendency, but we have not the solution. Obviously, we can solve this problem by using more sensors. Yes, but sorry, don't forget, you need to place the sensors, and this is technologically many times very difficult, and the sensor has a price, a cost. And obviously, this becomes very, very fast, very, very expensive. The other difficulties of a database approach is it's difficult to explain this result. It's not the case when you are using models. The things that you cannot explain is difficult to certify. And when you are using models that are based on data, interpolation is a safe procedure. Extrapolation is very delicate. And when you are in high dimensional spaces, in general, you must extrapolate. And extrapolation is always in science and engineering a very tricky issue. So finally, I will introduce my fundamental equation. My fundamental equation reads, the reality is the things that you know, the physics-based models, the art of modeling, or maybe also the art of simulation, plus all the things that you ignore, that I call it the ignorance. And you can read this equation, reality is knowledge plus ignorance. And this is the foundation of the so-called hybrid paradigm. We have the models, and we are taking these models that are based on physics, that I understand, that I can explain, that I can certify. And if there is something in the reality that is not represented in the model that we call ignorance, I will take the data, the deviation, only the deviation, not the solution, the deviation, the difference between my predictions and the measurements, the reality. And I try to use artificial intelligence to create the model, not of the reality, only the model of the ignorance. So we are putting together the art of modeling based on all the knowledge that we have at present, that is coming from centuries of science and engineering. And if it's not enough, we are trying to create a model of the deviation of the gap that we call ignorance by using the data and using machine learning, artificial intelligence. And this is the foundation of the hybrid paradigm in order to proceed fast, accurate, the capacity to explain, not too expensive, because as is represented in the figure on the right on the bottom, now you can see that the reality that is the continuous red curve is the model that is continuous red plus the deviation. And the deviation, that is the difference between both, is the discontinuous blue line. You can see that in general, not always, but in general, the deviation is smaller than the solution itself. And when something is small, it's quite linear. This is the definition of the derivative. And when something is linear or reasonably non-linear, few data is enough in order to represent it. In this case, only in this case, 2 data is enough to create the straight line that represents the deviation. So finally, a model that is not perfect, but is not stupid, plus 2 data, only 2, is enough to represent, in this case, the reality that is this continuous red curve. And this is the main ingredients in the so-called hybrid paradigm. What are the 3 main protagonists in that? First, the data. Second, model based on physics. Third, model based on data. And I will treat in my presentation these 3 ingredients. First, we are focusing in data. Sometimes data is very easy to understand. If it's a temperature, you have 100 degrees, you have 200 degrees, and you can make operations with this. You can make subtractions, you can make additions, you can make plenty of things. But sometimes the data is more complex. For example, we can assimilate one data to the identity card or a woman or a man. And this is a problem because this data contains multiple heterogeneous information. The first name, the name, the date of birth, etc., etc. Okay, so this is a data. Each identity card is a data, and is the data that is needed for, I don't know, the police in order to describe each one of you. In general, when we have reasonable data, numeric, real numbers, we can make plenty of things with this data. We can proceed to unsupervised clustering. This means from the data, I try to create clusters such that, in this case, I decide to create 3 on the left. After creating the clusters, I assume a color in each one, red, blue, and green. But after creating the clusters, with one property, each red dot is closer to the center of gravity of the red population than to the center of gravity of the other populations. This is something that is very usual that we call K-means. K-means is an unsupervised clustering that tries to group the data, to put the data in groups. And for that, the only information, the only metric is, for example, an Euclidean metric. I need only something that, in this case, that we are measuring and we are clustering. We can also proceed to classify the data in a supervised way, as represented on the right, in which I try to create or to deduce what is the optimal interface that separates the blue population and the green population. The color is known in this case, and for that reason, we call it supervised. The only thing is to find the best red line in this case in order to separate both populations. And again, in order to quantify distances, we are using a metric, as indicated in the slide, in general an Euclidean one, but not only, in order to manipulate the data. This is very usual, and in particular, this is very easy. My problem is sometimes in engineering, we are using data that is not real numbers. And after I would like to compute the distance between Martin and Chevalier. And now it's clear that there is not a metric in order to proceed to group this data, create groups or clusters and proceed with this data as we proceed when this data is numeric. And this is a real issue, not only in this case that I'm trying here to discuss, but in the case also of real data in engineering. And there are two cases that are very important in engineering. The first one is the time series. You can take a time series, and I can guarantee that in general, you never find another one that is exactly the same. Even your heart today is at having a rhythm, and probably tomorrow at the same time, it will be something similar, but not exactly identical. And we need a metric in order to compare time series. And obviously, this metric is not the value of the field at each one of the time steps. The same for complex images. Imagine a foam like in the bottom on the left. This is one photography of one moose. If you take in another place and in another place and in another place, the moose is similar, but it's not exactly the same. Pixel to pixel, the distance is very, very large. Like two trees in the street, the trees are similar, but similar in a certain metrics that in general is not the Euclidean one. And for that, we need new ways, new metrics in order to compare complex data like time series or complex images. And for that, one possibility is using the topological data analysis. This is our choice. There are many others, but I explain the choice that we retain in our research. That from all these time series or complex images, we are creating something that we call the persistent image. This is the scientific word. For me, this image is that is in the center with the blue, pink, and yellow. For me, this is a sort of QR code that describe the time series or the images, a kind of passport, a kind of goal-oriented descriptor that now with good news is in a vector space. And when you are in a vector space, you can use all the artillery that we have in machine learning. The question is how to move from a time series to a persistent image with one particularity. All the time series that has the same topology have the same image. Your heart today probably has something that will be different to the rhythm tomorrow, but time to time, if you compare the value at this time, but the persistent image will be exactly the same. This is the very good news. So this is a concise and complex descriptor or very complex objects like a time series or images. How to compute a persistent image? Imagine in the figure on the left, a time series like this one. First, in order to extract the topology, you identify local minimum and local maximum that are neighbors. And you can see we have the red squares, 11, 14. You have the green squares, 7, 9. You have the blue squares, 9, 10. This is pairs of min-max, local min-max that are neighbors. And as soon as you extract this, you represent in the diagram on the right, in which you have the mean in the x-axis, and you have the max on the y-axis, that we call birth and death, because obviously the max is always higher than the birth, and the max is higher than the mean. And you can see I represent the 7, 9, I represent the 9, 10, I represent the 11, 14. And this is the topology of the time series independently if the red appears before or after the green or the blue. It irritates the properties of topology, invariance properties of topology. As soon as you have the persistence diagram, you can obtain the lifetime diagram that is the same. The one in the right is the same that the one on the left, but now you represent in the y-axis not the death, but the death minus the birth. This means the distance of each point in the left diagram to the diagonal. And like this, you obtain these 3 points that are 3 Dirac masses, and this is difficult to proceed with this. And for that reason, we take this. We apply a convolution by putting in each one of these points a sort of Gaussian. And after, in this space, that is the space of the persistent image, you evaluate at each voxel, at each small square in the image on the right, the accumulation of the contribution of each one of the Gaussians on the left. And like this, you move from the time series to the persistent image that describe in a vector space the topology of your data with the very nice property that data that has the same topology, even if located at different time instants, they have the same persistent image. And this was used in order to classify rough surfaces like the one that appears on the left. As you can imagine, if you take the surface that is at the rough surface and you consider the roughness, obviously, even for the same material, if you take at different places, the surface is different, but the topology is the same. And you can classify as soon as you translate this time series into persistent images. If you move to the right, you have a driver, and depending on his state, tense, relaxed, tired, etc., you can visualize the movement of the head that you can record with a camera. And after, depending on the vibration of the head, you can obtain different signatures, that is these persistent images. And all the guys that are tense, all the guys that are relaxed, all the guys that are tired, etc., they have similar persistent images. And this allows you to obtain or to classify with very, very high accuracies, like in this case, greater than 96% of confidence. We can use in order to make diagnosis, like in the case on the left, you have different time series, and this is an industrial case, all these are industrial cases, of course. And you have something that is the nominal state as indicated, that, okay, this is nominal, but if I compare time to time, they are very, very different because obviously this is not the right metrics. If you move to the persistent diagram, the lifetime diagram, and the persistent image, you can see that nominal is nominal, and that after these patterns that you can see in the first row, each one indicates a kind of fault, the fault A, B, C, D, E. And this is the pattern. And if you now make pattern recognition, you can make diagnosis in real time. Obviously, the same kind of topology can be extended to images. I have no time to describe, but you can define exactly the same entities. And finally, each microstructure can be described by an image of persistence. And like this, you can see that the different topologies concern different images, and you can use it in many, many applications. So I will move to the next topic. This is the way that we are using in order to transform complex things, complex entities like time series or complex images in material science or in other domains into something that I can manipulate using standard metrics like the Euclidean one, as soon as I translate this information in the right space. Now we are moving to the second protagonist. The second protagonist is physics-based model. Now the data is clear, I can describe it, I can measure, I can compare, I can classify, I can make plenty of things. Now it's time to move to the first term in the fundamental equation that is the physics-based model. We need to solve these models that are coming from the art of modeling, and we need to solve them in real time. And this is the art of simulation. And for that, we are using model order reduction, and in particular, one technique that we are developing. There are many. I'm focusing in the PGD because it's the one that we are developing, but obviously you can use your favorite technology. PGD is something that serves to create parametric solutions. You have a differential operator that is acting on a variable u that depends on a space x time t and a series of parameters mu1 to mu_m. Obviously, my idea, or our idea, is to introduce these parameters as extra coordinates. And now u depends on x, t, mu1 to mu_m. And the only problem when making this, you are computing a solution not only at each time, not only at each point, but also for any possible value of the parameters mu1 to mu_m at any value of these parameters in their domain of definition. Obviously, when you are making this, your problem that was 3D transient now is multidimensional. And in order to circumvent the curse of dimensionality, we propose using many years ago the separation of variables. That is something that is very well known when you are solving partial differential equations at hand. We introduced this technology in an algorithm in order to describe this multi-parametric solution as a sum of functions that depends only on x, functions that depends only on t, and a series of functions that depends each one only in one of the parameters. And we produce, or we propose, obviously, not only the use of the separated representation, but also the algorithm that is able to compute functions xi, ti, and pij. And this was more or less a few years of intense research in which we propose many technologies to accomplish to the calculation of these parametric solutions that after can be used in order to make real-time engineering. This is excellent for publishing papers, but the problem is, in order to use this in industry, this is difficult because even if the only thing that changes is the representation of the solution, you cannot insert this directly in a commercial software. And for that reason, this was excellent to publish, but not excellent to use. And for that reason, in collaboration with ESI, in the context of an international chair of research, we decided to create metamodels, surrogate models, that are based on the use of sparse samplings of the multidimensional parametric space. You select few points in a high multidimensional space. In each one, you are running a high fidelity solution. You are trying to compress the space-time solution by using any technology like the POD, PGD, CURE, AIM, or cross approximation in order to define each one of these solutions as the sum of products of space modes, the blue vertical arrows, and the horizontal one in red that represent the mode, the time modes. And for the product, you can represent your high fidelity solution. This is only too complex because many times these solutions are very, very big. And as soon as you know this decomposition for each value of the parameters, you make an interpolation with some properties in order to obtain the parametric behavior. And in this case, we assume that there is only one parameter and the modes that represent the evolution in this parameter are given by the modes in yellow. The product, the tensor product of the blue, yellow, and red give you a kind of hypercube in which you can find the solution at each point, at each time, and for any value of the parameter. And this was the technology that we follow. And this is not new. Metamodeling is very, very, very standard. Surrogate models are very standard, making samplings, making high fidelity simulations, and interpolating. All this is extremely well known in the community. So this is not our contribution at all. Our only contribution in this business was the fact of addressing many parameters. And when we are addressing many parameters and using exactly the technology that is used in the construction of surrogate models, but by using the separation of variables. There are many technologies. The polynomial one, we are not using it because obviously we have problems of overfitting. We need a lot of points, and we are considering polynomials in high dimensional spaces, and this is quite tricky. We propose many other technologies to create these surrogates based on the separation of variables. For this reason, you can see in blue that there is PGD in all the columns. This means separation of variables. Each time that you see PGD, this means separation of variables. And when you see, or when you read that there is an S, this means that we are using an sparse sampling. It's normal because our parametric space is very large. And in order to increase the accuracy, we are using regularizations based on sparsity, in particular the elastic net that combines the ridge and the lasso, the ridge that limits the overfitting, the lasso that is looking for sparsity. And when you move to the last column, there is the ANOVA. That is something that is very nice because you have an approximation basis with the properties of orthogonality. So we are implementing all these technologies. In this slide, I put some information in green, some advantages, and in red, some drawbacks. But obviously, you are interested in more details. All this is published, and we can share with all you. When you have, obviously, more than creating a very strongly nonlinear regression, sometimes we take the solutions, we clusterize all them in order to put the black and the violet, because they are very, very close, by using a metric, obviously. And we create, instead of only one regression for everybody, multiple regressions, each in each cluster. And then online, as soon as someone decides the value of the parameters, we identify the cluster. This is a classification, a usual classification in machine learning, and then we particularize the solution in that cluster. And like this, we can obtain things like this. We simulate crash in realistic settings, more than 5 million elements, 20 parameters, 20 runs. And at the end of the day, you have something in which you move the buttons and you can particularize the solution. So this is the PGD, or the surrogate model based on the PGD, because there is the separation of variables in real time, in which now you can see on the right, on the bottom, that you can change the parameters in real time after constructing this parametric solution and evaluating the impact of the parameters in the solution. So there are many other examples. This is for the airbag in fluid mechanics, etc. I have no time. If you are interested in this, it will be in my presentation, but I will move to some more recent things. Obviously, in some cases, when you have solutions that localize, imagine that you have the solution that for one parameter is the blue curve, for another one is the orange curve. If you take a parameter that is in between, you will have the half of the blue and the half of the orange. And I don't like this. I would like to have something that is the half, but located in the middle. And for that, recently we combine parametric models, surrogate models with optimal transport. As you can see here in a problem of fluid mechanics, you can see that by changing these two parameters that are related to the direction of this vent, we can produce the solution, and this solution is not polluted numerically by the interpolation because we are using this parametrical optimal transport. Sometimes also we need to produce parametric solutions for taking into account the uncertainty propagation. And in this case, for example, in material modeling, we know that we have a constitutive equation, but the parameters k epsilon 0 n in this Krupowski law are not perfectly defined, are more than a parameter is a distribution. There is a certain average and a certain standard deviation. And for that reason, now we are decoupling. And as soon as we define the parameter, we work with two kinds of parameters: the average, the mean value, and the standard deviation. As soon as you create this, by changing the parameter, you are moving this curve, that is the traction curve. But you can see here, if I introduce as parameter the standard deviation, we are creating a sort of corridor that guarantees that if the mean is this one and the standard deviation is the parameter is this one, you can explore your solution will be inside the corridor for the plastic region and for the deformation at the breaking point. So this is good news because this is extremely important in uncertainty propagation and in particular in robustness analysis. And obviously, we are also introducing this in collaboration with some important groups in the sensors. And this is a sensor in which we are introducing the physics inside. And this is in order to obtain the pressure in some point during the injection of a resin. And the parameters are the parameters related to the permeability, the thickness, and parameters that are related to the curing, the polymerization of the resin. And you can see that by taking the mean value and the standard deviation, because there is a lot of uncertainty and variability in this kind of modeling, we can obtain the corridor that if we are inside, we are 95% confidence on is compatible with the statistics that we take at the level of the parameters. And as soon as we have this kind of modeling, you can imagine that we can create parametric models at the level of the component. And now you can assemble these models in a system. And you can see here on the left for lever, for a landing device, that finally we can create a high fidelity model. That is the one that you can see here, that is parametric with respect to the loading during the landing. And you can introduce this in a system modeling by using Simulink, Modelica, or Simulation X. And you can obtain something that runs at the same speed that a standard system modeling, but you can put inside the 3D resolution. And we are creating this for the different components. And after we need to assemble all them, and we call this technology the Lego PGD that we are using today to decompose a car in many substructures and assembling all these structures to compose the car and to evaluate the crash in the system. All this is nice, but all this is solving very fast physics. But the problem, as I just mentioned, is what happens if finally the physics is not good enough. In that case, as you remember from the beginning, from the fundamental equation, there is the ignorance, that is the gap between the reality and our model-based predictions. And now, from this deviation, from the data that is coming and that is expressing this deviation, we need to decide and we need to create a model based on the data. For that, following the words of Elias Cueto with his colleagues at the University of Zaragoza, Elias proposed to create or to learn models or to learn physics that fulfill the first principle of thermodynamics. This is quite common in Hamiltonian mechanics. This is not so common in general mechanics, in which you have also dissipation. And in that case, Elias Cueto proposed to consider generic, in which the state of a system changes with a part that is reversible. This is the Hamiltonian part that concerns the gradient of the energy in the phase state, in the state space. and a part that describes the dissipation, that is the gradient of the entropy. And after these matrices that appears, L, the Hamiltonian H, the dissipation matrix M, and the entropy S, all this is learned from the data. And as soon as you learn all this from the data, you have a system that can fulfill the energy conservation and that is dissipating energy, and this is very important in order to obtain stable integrators. And with all this, Elias, with all the group, and many young researchers are probably connected today, introduce all this, use autoencoders in order to extract the intrinsic dimensionality of the problem, and in the hidden level, he introduced this structure preserving neural network in which, in the loss function, appear the fulfillment of the thermodynamic consistency properties. And from all that, Beatriz Moya performed this extremely beautiful simulation in the team of Elias Cueto in Zaragoza, in which they try to learn the behavior of a fluid in a container that is moving. And as you can see, they perform the training for different of non-linear fluids. Some ones are obviously non-Newtonian fluids. As soon as they obtain this data, they generate synthetically the data. After they learn by using all these technologies, the model that can be used in the integration of the dynamical system. And after they try to introduce the virtual fluid into the real container. Here you can see the hand, the container is real, the fluid is virtual, but you can see it learns perfectly the equations of motion, and the accuracy is very, very good with respect to the reference solution. So this is more or less the perspective in the sense that we can use today data that we can represent in different ways. We can use regressions by using this separator representation when there are many, many parameters, or we can use this data and introduce in a standard convolutional neural networks, and we can create the models to move from the data to the performances in mechanical systems. And after, the only thing that we need is to reconcile these two words, the analytic knowledge from the past on the left, virtual prototyping, this is the classical simulators that we can speed up by using model order reduction that, as just proved, we can introduce in the system modeling to perform simulations in very complex systems. And obviously with this, we are moving very, very fast, but we are not sure that we are very, very accurate, because models, as you can see, are more complex. Reality is much more complex than our models. In that case, we consider the part on the right. There is a gap, and now we are in the digital world. We take this real data of the gap of the ignorance. We apply data analytics that is in accordance with the first principles. We can construct the model, we can integrate in the system model, we obtain a sort of digital twin of the ignorance. And now, by mixing the virtual twin based on physics, the digital twin of the ignorance based on data, we have this hybrid twin that is a concretization of the hybrid paradigm that I introduced before. So I have no time to discuss one example, but this is irrelevant. And now two views. The first one is we introduced this paradigm in, this was Abel San Carlos, that is a very clever PhD in the group, that is co-supervised by myself and Elias Cueto, that create a model of the electrochemistry in the battery based on all the electrochemical equations. From this, we use model order reduction, POD in that case. And from this, we obtain very, very fast solutions that we use in order to create a parametric model in order to obtain the state of charge or the voltage at the level of the battery. And Abel introduced this in a system modeling that is the electric car, connect all this with OpenStreet in order to planify an itinerary for moving to the point A to the point B. And obviously, from that, we can in real time predict an history of the evolution of the state variable, the state of charge, and the voltage. And obviously, reality sometimes is a little bit more complex if there is a deviation that appears, because when you start your travel, something occurs. At this moment, you realize that there is a deviation, and now you apply the hybrid twin paradigm in order to construct the model of the deviation, and like this, you have always your system in which your predictions takes into account the real state and not the one that you use at the beginning. Last example, this is from a system in avionics, Dassault Aviation, in which they have obviously a system modeling, as you can see on the right on the top. And as a system is very, very complex, you can imagine an aircraft. They describe all this by simplifying the components that becomes 0D or 1D. They assemble all this in something that is a Modelica, using the Modelica language, something like Simulink or Simulation X. And from that, you can imagine that you can compute fast. But as you simplify a lot the description of your system, you are not sure if this is or not in agreement with the measurements. So they decide with us to use this model, because this model is the knowledge that Dassault has. And with this, they make predictions. This is the red arrow on the right. They take predictions and they compare with the measurements and they make the subtraction. This means prediction minus measurements. And obviously, if it's 0, this is perfect. The model is good. But if this difference is not 0, this means that there is a deviation. And we need to understand if this deviation is due to a fault. In this case, this is diagnosis. If not a fault, is simply because the model is not good enough. We introduce this deviation, as just mentioned, in an artificial intelligence, in a machine learning technology that produce the model of the deviation between this model and the measurement points. And now you agree with me, the output of this machine learning model is the model of the ignorance. Now you have the fundamental equation. Your simplified model plus the model of the deviation, you agree with me. This is close to the reality. And as you can see, if the real data is the blue and black curve that you can see on the left, again, Abel San Carlos learned the model of the difference. And when you superpose the predictions with the data, you can see that despite of the noise, you can obviously describe this solution very, very well. So this is more or less the main idea of the hybrid paradigm. Last slide. People remember very differently what they learn after 2 weeks. 10 to 20% of what they heard or read. 90% of what they did. This means in order to learn better, we need to interact with physics. We need to touch. And this is the work of, again, Elias with the young researcher, Alberto, Bea, and plenty of people there, also David Gonzalez and Isiar Alfaro, and they try to use model order reduction, and they try to put all this in a virtual world or in a hybrid world in which you can see the Stanford Bunny is virtual, but the office is real. And now where we have this model order reduction, the PGD solutions, we can interact with the bunny. And obviously, this is a real nonlinear behavior. This is an hyperelastic material. There is some approximations of the contact law in order to avoid the interpenetration. And you can even enrich, this is the dragon, the Stanford dragon, and you can touch. You can even using colors in order to emphasize the different fields in the dragon. And obviously all this for any point in which you are interacting with your system is proved in few seconds. And obviously you can see when you are touching, you represent obviously the stress fields and the deformation fields everywhere in the system. On the right, no time to present this video, is the same by using holography. And this is an excellent word because finally, in the future, these kind of hybrid twins, they will use data. There is physics, and this is very good news because with physics, we are not so far from the reality. If the reality is a little bit more complex, we are using the data in order to enrich models, and models allows data to be a little bit smarter in the sense of knowing which is the pertinent data and where and when measure this data. This is extremely important, and this is the difference between the big data and the smart data context. And finally, when we are creating these avatars, these hybrid twins, we need also discover new ways of interact between these virtual realities, and this is all the research that Elias with Alberto, David, Iciar, etc., and Bea, they are developing very, very smartly at the University of Zaragoza. So this is all from my side. Few items in the conclusions. Probably the best paradigm is this hybrid intelligence. It's clear that today we need to ensure performances by design and performances in the design. We need to augment the human. The next steps is to interact with this virtuality in a multisensory and emotional way, and not only by the visual feedback, like in the previous cases, and all this obviously to empower humanism and in the context of the art of decision-making in a more realistic world. So this is my vision, and this is the end of my presentation. Thank you very, very much.
Welcome, Francisco, Professor Chinesta, for this presentation. It was really interesting. It's something that happened when I was working in France with you in this case, that we dream as young researchers to do things like this in the future. You always inspire to young people. Thank you very much.
Thank you very much, Enrique.
We have two questions from Philip Omasi. The first one say, thank you, Professor Chinesta, for your extremely nice presentation. I have a question regarding the surrogate model strategy you proposed. How physics are assured with the research of surrogate models?
There are two parts in the response. The first one is we are using to create the surrogate models, and there are error indicators that are based on the solution itself or in quantities of interest. We developed this in the past in the case of intrusive model order reduction, in particular in collaboration with Pedro Diez and Antonio Huerta. So first of all, we control the accuracy of the solution that we are computing, and we try to discover which is the new point in the parametric space in which we need to compute a new solution in order to improve the solution. So first, we try obviously to improve the solution of the surrogate in order to approach the real parametric solution. This is quite easy. As soon as you are in the interpolation region, this means in the convex envelope of the data. When you are moving outside, and this is the case when you have many, many parameters and few data, in that case, we need a control, because as soon as we are in the extrapolation, we can observe that very, very fast the error increase. And this means that with our indicator, we need new data in this region. So we are using something that is very similar to the refinement in finite elements. When we estimate that the error is important in one region, in finite elements, you make a mesh refinement. In this case, we use a sampling refinement. Second part of my response. Sometimes, even if the solution is not good, if we are trying to couple this surrogate in an hybrid paradigm, even when the solution is not good, you can use the data in order to enrich the predictions. So this means sometimes I'm not interested in a very good surrogate model, an acceptable surrogate model.
And if the reality is different, I will take the difference and I will create, by using these machine learning technologies, the model of the difference. Like in the case of Dassault that appears in my case, in which, imagine, this is not a surrogate model. This is a system modeling based on 0D and 1D behaviors. In this case, the solution is very fast, but it's not very good. And this means I don't need to refine the model. I take the model as it, because if it's not compatible and in agreement with the data, I will correct later. So obviously, if the surrogate is to use as it, I need to prove that the surrogate is good enough in order to ensure the tolerances in engineering. If it's in order to move and to insert it in an hybrid paradigm, in a digital twin, in an hybrid twin, I have more freedom. I take the model. If it's not good, it's not a real problem. It's not a real problem, because after we have an amount of data, with the difference of this data with respect to my poor, maybe poor surrogate model, we are trying to create the model of the difference. This is the procedure that we are following.
Thank you, Francisco, for the answer. So we have a second question, also from Filippo Masi. How physics is assured, if so, within the training architecture of the sparse autoencoder?
The sparse autoencoder is not to represent the physics. The sparse autoencoder, we are using it because we know that when we have, for example, a fluid, all the particles in the fluid are not defining the real state space, because there are many, many correlations. Like in model order reduction, you have something that is very rich, the finite element solution, and finally you have few modes. In this case, the model order reduction, you can apply PCA, or you can apply any nonlinear model order reduction like kernel-based PCA, LLE, or many other techniques, or you can use an autoencoder that finally is extracting the intrinsic dimensionality. That means the reduced model. And as soon as the autoencoder reduces the model, after we apply or we assume that this reduced model that we don't understand, because it's finally the autoencoder that is producing it, independently of understanding or not, we need to be sure that it fulfills physics. And for this reason, at this level, we apply again the thermodynamical consistency that is only, we would like something stable, and for that, the production of the entropy should be positive, and we try to enforce the energy conservation. But the autoencoder is something that make a reduction, reduce all the degrees of freedom that we have initially, like in finite elements, to obtain few parameters that, in this case, these degrees of freedom of these neurons that appears in the internal case represent the coefficients of the reduced mode that can explain in a non-correlated way the initial fields. So obviously, as soon as it exists, and we need obviously to prepare and to know which is the size of this internal, only in order to take the solution that we have in the training and apply the coding and the decoding. And if we arrive to the code and to arrive to the initial state, and we reduce, and in any case, we reduce a lot in this internal layer, is at this internal layer that is the reduced model, but instead of use manifold learning, we are using, in this case, autoencoders, is in that place that we ensure only, obviously, the thermodynamical consistency, and after, in order to compute all the weights that appear in the neural network, we are using adequate losses function in order to train the system. So the autoencoder is a sort of model order reduction, but a little bit more timely, because instead of using something that we understand that is manifold learning, we are using something that we don't understand.
Thank you, Professor Ginesta, for the answer. Also, Filippo, thanks for your.
Thank you, Filippo.
So we are now running out of time, and the next parallel session will start in 25 minutes. And I recommend the speakers to go to the rooms and try sharing the screens and their presentation before starting the panel session at 11:30. Thank you very much for attending the conference and see you around.
Thank you very much.
Thank you.
Thank you.